Hello students, welcome to this educational video on probability. Before starting, let us see the aims of this lesson. By the end of this lesson, you should be able to understand and define the concept of probability, define the different terms in probability, identify and justify the different types of events, that is, the mutually exclusive event and the independent event, to understand conditional probability, and to draw a possibility space diagram. Let us now see the concept map on probability, that is, all the terms connected to the term probability. We have the terminology, that is the sample, the event, the random, the possibility. We have the definition, the probability of an event occurring is a chance that this event will occur. We have the scale probability, that is, it should lie between 0 and 1 inclusively. We have the condition, that is the independent, the mutually exclusive, the conditional probability, and the example we have the cards and die. Also we have the possibility space diagram. Let us now define some important key terms. What is a random experiment? It is an experiment, trial, or observation that can be repeated numerous times under the same conditions. For example, the roll of a die and the tossing of a coin. Outcome: a result of an experiment is called an outcome. For instance, when throwing the die, a 6 can be obtained. The set of all possible outcomes of an experiment is called a sample space and is denoted by a capital letter S. For example, when you roll a die, the sample space is 1, 2, 3, 4, 5, or 6. An event is a subset of the sample space. For example, in rolling one 6-sided die, the event of getting prime numbers are 2, 3, and 5. What is probability? Well, there is a lot of definition on probability, but let us see a particular definition on probability. It is the likelihood or chance of an event occurring. A fair random experiment shows that all outcomes have an equal chance of happening. For example, the probability of flipping a coin and it being heads is half, because there is one way of getting a head and the total number of possible outcomes is 2, that is, a head or a tail. Another example is in the case of throwing a fair die. The probability of rolling any number is 1/6. In general, we can say that the probability of an event happening is found by the following formula. Probability is equal to the number of favorable outcomes over the total number of outcomes. As you can see in the given example, we have red marbles and blue marbles. So the total number of outcomes is the total number of red marbles and the total number of blue marbles, that is 12. Now, if we want to find the probability of getting red marbles, we take the number of red marbles over the total number of marbles, which is 7/12. The same applies for the probability of getting blue marbles. which is 5/12. Two events A and B are said to be mutually exclusive if they cannot occur at the same time. For instance, it is not possible to obtain a 6 and a 5 when an ordinary fair die is rolled at once. So, if A and B are mutually exclusive events, then the probability of A intersection B is equal to 0. Another example of a mutually exclusive event is when throwing a 6-sided fair die, the outcomes of it landing on 6 or 1 are mutually exclusive. It is an independent event. Independent events are events where the outcome of one event does not affect the outcome of the other events. Example is tossing a coin and rolling a die are independent events. Why? Because let's say A represents the event the number shown on an ordinary die is 5. And B represents the event that a coin lands head showing. Clearly, A and B are independent events, as obtaining a 5 on the die does not prevent us from obtaining a head by throwing a coin, right? So, if A and B are independent events, then probability of A intersection B is equal to probability of A times probability of B. Let us see an example of independent events and mutually exclusive events. So guys, here you need to analyze the questions well, and you need to know your definition of independent and mutually exclusive for you to be able to attempt this question. Okay? Events A and B are such that probability of A is equal to 0.2, probability of B is equal to 0.3, and probability of A intersection B is equal to 0.12. State giving a reason in each case. So you need to mention why it is independent or not and why it is mutually exclusive or not. Whether events A and B are independent, mutually exclusive. For probability of A intersection B means the probability of A times probability of B. Okay, this is the definitions of independent. So let us now see. The probability of A times probability of B is equal to 0.2 times 0.3, which gives us 0.06. As you can see, 0.006 is not equal to 0.12. Probability of A intersection B is not equal to probability of A times probability of B. Therefore, A and B are not independent. Now for part 2. The probability of A intersection B is equal to 0.12, which is not equal to 0, right? Therefore, A and B are not mutually exclusive. Conditional probability. Conditional probability is the probability that an event will occur given that another has already occurred. If A and B are two events, then the conditional probability that A occurs given that B has already occurred is denoted by probability of A vertical bar B. And here the vertical bar is the given. Okay, so how will you notice that this question is based on the conditional probability? The term here is given. So when you see the term given, means you need to apply the formula for the conditional probability. If we need to find the probability of A given B, we need to use the following formula. Probability of A and B over probability of B. See an example of conditional probability. As you can see in the given table, a survey is carried out to find the number of times students, that is full-time or part-time, visited tutoring. Now, if we wish to find the probability of 4 or more times students visiting tutoring given full-time students, so here we need to apply the formula for conditional probability. So, we need to find the probability of 4 or more times over probability of total number of full-time students. So, the result is 8 over 45 or 0.18. Possibility space diagram. When is it useful? It is useful when an experiment is repeated twice, or when 2 experiments are performed at the same time. For example, when a die is thrown twice, or when 2 coins are tossed, or a die and a coin are thrown simultaneously. That is, when 2 events occurred at the same time. Let us now see an example of how to make use of a possibility space diagram. Let me read the question first. 2 six-sided dice, one colored red and the other blue, are thrown together. Given each answer as a fraction, find the probability that, firstly, the total score is 8 and the total score is a square number. As you can see that 2 events are occurring at the same time, so it is convenient to display all the possible outcomes on a grid. Since the question is asking for the total number of score, so we need to add the 2 dice together. The first question is to find the probability of total score is 8. So we need to count how many A's we have in the possibility space diagram. If we count, you will see we will get 5. Since the possible outcomes of the 2 dice are 36, hence the probability of total score is 8 is given by 5 over 36. Now for the second question. We need to find the probability of the total score is a square number. So, what are the square numbers that we have in our possibility space diagram? We have 4 and 9. Again, we count how many 4s we have and how many 9s we have. In all, we have 7. Hence, the answer is 7 over 36. Before we end this session, let's do a summary of what we have covered so far. Firstly, we have seen the definition of probability. The probability of an event occurring is the chance that this event will occur. It is given on a numerical scale from 0 to 1. We have seen that all probabilities are between 0 and 1 inclusively. Now, to find the probability, we make use of the following formula. The number of favorable outcomes over the total number of outcomes. We have seen 2 events, the mutually exclusive events and the independent events. If A and B are 2 mutually exclusive events, then the probability of A and B is equal to 0. For it to be an independent event, the probability of A intersection B is equal to probability of A times probability of B. Lastly, we have seen conditional probability. Probability of A given B is equal to probability of A and B over probability of B. My dear students, this comes to the end of this lesson. I hope you guys have enjoyed this video. Thank you.